All right, well, good morning and welcome to Tea Science Tuesday. Today we're talking about fermented teas, and I'm drinking some puer. I know Eric, who's on the stream, is drinking some Fujuan. So, yeah, I'm going to go ahead and pour it. It's like perfect timing, right? So we get to see this nice dark color, and we'll talk a little bit about sort of the chemistry of that, just a little bit. But before we get started, I got show and tell for you guys, because I have a tea plant, potted in a pot, and I keep it outside of my balcony in the summer, and then in the winter I bring it in, and it's starting to get cold. It could freeze, any day now. So I've got it in my living room, and it's flowering. So I'm gonna really ask for trouble here and take my phone off the very makeshift tripod I have and flip the camera. And there's my tea plant. Yay. It's got one beautiful, fully opened flower. It opened yesterday. So yeah, it's like, it's small for a 5-year-old tea plant. But, not bad for being grown in a pot in Boston. It's doing all right. I sort of doubt any day soon I'll be able to make tea from it. But it's hanging in there. It's doing all right for being in Boston, for being indoors for part of the year. Nice thing about tea plants is they're really pretty shade tolerant, actually. They're understory plants like coffee, right? So they're sort of like sit and wait until some bigger tree dies and there's a gap and they can take advantage of that light. Ooh, I have another show and tell. You guys probably already saw. I found these really cool brass coasters at a vintage sale. Woo! They've got bats on them. This is a bat, and the inside has a stylized longevity character. I really like them. They're not like fancy. This middle part is stamped and enameled and just tack welded on. I could just rip it off if I really wanted to. I could pry it off. So it's not like these are, super well constructed. They're definitely mass produced. They've got a stamp that says China on the back. But I feel like they've got a good deal for them, and I'm happy about them. I've been looking for something like that for a long time. So now that the weather is getting cold, I do occasionally like to drink puer. I feel like it's tasty in the cold weather. And we'll talk all about fermentation and how it's made and how other fermented teas are made. But where I'm going to start is with the word fermentation. Fermentation versus oxidation. So there's a tea memes Instagram account, believe it or not. And there was something the other day that Jeff put up about oxidation versus fermentation, and there was of course lots of discussion in the comments. And this is one of the things that even if you've sort of been drinking tea for just a short amount of time, you've probably heard someone use the term fermentation to refer to how black tea and oolong tea are made, and maybe been confused. And so I'm going to start by trying to work through that confusion a little bit. So in English, as far as I know, in all the English dialects, fermentation implies that there's some microbial activity, that there's microorganisms at work. So we think of, beer is fermented, right? Wine is fermented. Some kimchi or cabbage or sauerkraut, those are fermented, right? And they're fermented because there's microorganisms that are transforming, that are eating that food and transforming it in some way and producing a new product. So in my opinion, that's what fermentation is always. That it always has to have some microbial component, at least in American English. I can't speak for all dialects of English, but yeah. So using fermentation to describe the production of oolong or black tea is confusing. Because there's there's microbes everywhere, but the main transformation going on there is not because of microorganisms, right? So why is it like this? Well, my best guess, and I'm not a linguist, and I'm not bilingual in Chinese, and I wish I was, but my best guess is sort of a translation mishap, where what happens is words don't always map perfectly onto other words in other languages. So another example with Chinese would be the color green. So in Chinese, there's two words for what we would they would both be translated as green. So there's qing, which is like kind of a darker, more foresty green, kind of like a bluish green, I think, but not like blue-green, and not blue, definitely not blue. There's another word for blue. And then there's lu, which is usually like a brighter green, more of like a yellowy or green. But again, not yellow-green, because like it's not yellow. There's a word for yellow. But both of those get translated as green because we don't distinguish between those in English. We don't have a word. We don't have two separate words for those colors. We just have one word. And so fermentation is kind of the same way going the other way. So in Chinese, fajiao is fermentation, but it describes what happens to beer and wine, but it also describes what happens to an apple when you set it out on the counter and it turns brown, or a potato, right? I think. Again, not fluent in Chinese, not a linguist. So if I'm wrong, please correct me. But yeah, so fajiao is the term that's used in the industry, in the tea industry, to describe what happens to black tea and green and oolong during processing. But it shouldn't be translated as fermentation, in my opinion, because that's confusing. So what would we call it? I usually would call it oxidation. I think oxidation is probably the best term because that's something that is pretty relatively commonly used in English. Like people kind of know, like many people have a sense of what oxidation is. So you leave a potato, you cut a potato, you leave it on the counter, it oxidizes, right? You'll see a recipe that says, put the potatoes in water to prevent oxidation. And you might kind of have an intuition of what that means. So I think that's a really good translation. It also prevents this confusion of what to call tea that's actually fermented, right? So you'll often see puer and other teas that are produced with microbes post-fermented. They're called post-fermented. That's a weird word for me. Like, I don't understand. Post what, right? It's like not even grammatically correct to just say post-fermented. I think what it means is it's fermented post-processing. Like the tea is processed and then that processed tea is fermented. And I think you have to have some way to distinguish it because if you're calling what you make black tea with fermentation, well, then you have to have a different word for the real fermentation that actually involves microbes. So in Chinese, it's hou faijiu. In English, we translated that as post-fermentation with a little hyphen. That's a bizarre way to do it, I think. So I tend to use oxidation for making oolong and black tea and fermentation for making fermented teas, what are called dark teas, usually in English. It's another area of confusion is that in Chinese, the word for what we call black tea is hongcha, which means red tea, and the word for these fermented teas in Chinese is heicha, which means black tea. But we don't translate it as black tea because that's confusing, because we already have a black tea, so it's usually translated as dark tea. So yeah, dark tea. Sorry, that was a lot of information. So oxidation for oolong and black tea, fermentation for heicha or dark tea. But in that tea meme post that I'm talking about, somebody in the comments said both are wrong. And I replied and I was like, let's, give people the benefit of the doubt. Both are right, but some are clearer than others for certain situations. The reason they said both are wrong, well, so oxidation is one of many things that happens during oolong processing and black tea processing. What's going on there is the polyphenols in the tea, the catechins, tea catechins, are being oxidized. But interestingly, that doesn't mean that oxygen is getting added to them. So in chemistry terms, oxidation happens whenever any molecule loses an electron. That's the definition of oxidation. So these polyphenols get oxidized, and then so polyphenols have all these OH groups on them, and when you oxidize them, you take off one of those protons, one of those hydrogen atoms, and that takes electrons with it, so it's being oxidized. And then that lone oxygen really wants to react with things. And so it just starts sort of sticking to stuff, like whatever it can. So it'll react with proteins, it'll react with other catechins, and it'll form larger and larger molecules that then have reddish or brownish colors. So theorubigins, theoflavins, these are the products of that. And that's what gives, black tea its color. And it's exactly the same thing that's happening to the potato that you cut on the counter. You're mixing polyphenols with an enzyme called polyphenol oxidase, whose job is, you guessed it, to oxidize polyphenols, and it's turning brown. And this is such a common thing that plants do that in food science there's a term for this. It's called enzymatic browning. So it's a little weird to me that in tea science, in the tea industry, there's so much confusion over what to call this process that makes fresh tea leaves into black tea, because in food science, there's already a term for that, enzymatic browning. That's the word for it. That's what's happening. Now, again, there's all sorts of other stuff happening too. There's volatiles being produced and other types of reactions happening. Hey, Lindsay. But I think, if you're a tea scientist, you should call it enzymatic browning probably. If you are just at a tea shop and chatting with your friends, oxidation is a pretty good term because, even though it's not 100% correct, it's less confusing than fermentation for sure. And we use it as sort of a catch-all of we know when we're talking to tea people, oxidation refers to all the stuff that happens when you make tea leaves into black tea or oolong tea. There's lots of reactions going on. Not all of them are strictly oxidation reactions in the chemistry sense. It doesn't matter. So fermentation, now back to our topic. Fermented teas, what to call them? This is also, again, in that tea meme post, this is also not technically correct because it depends on who you talk to, right? So for most people, fermentation just means, microbes are involved. But if you talk to a microbiologist, somebody that studies microbes, hello, Talking Tea Podcast. I'll be on it. I'll be on you tomorrow. Anyway, sorry. What was I saying? Yeah, if you talk to a microbiologist, they have a more strict definition of what fermentation is, right? So for them, it's not just microbes eating stuff, because that's everything they do, right? They study microbes. Fermentation is what microbes do when they're not able to get oxygen. So this is like when you make sauerkraut, you really got to press that cabbage down, get rid of any air bubbles, because you want fermentation to happen and not rot, right? You don't want it to get moldy and gross. You want a specific set of bacteria that are able to thrive where there's no oxygen around for that situation. So tea isn't really fermented. Puer tea, puer, it's not really fermented in that sense. The microbes that are involved are not the typical fermenters. They're microbes that like oxygen. And in fact, when you're making puer, they're turning that pile of leaves often as it's fermenting to keep oxygen in there. So what do you call this, right? What is the correct term for this? Well, we have an analog again in food science. Cheese is an example. So like brie, cheese, that's an example of a food that is transformed by microbes, but it's not fermented because the whole cheese rind is exposed to the air, right? And they're inoculating this cheese with I think it's a penicillium fungus, and it transforms that cheese into goo, cheese goo, right? It digests it, it makes it delicious, that tasty cheese goo. And we call that ripened cheese. It's microbially ripened product. And so that's what I think we should call puer if we're writing something technical or in science, right? That's the most accurate probably to describe it. But again, just chatting with your friends, we all know what fermented means. Nobody's going to be like, I don't think it's fermented because there's oxygen around, right? It's fermented. But the microbially ripened thing, realizing that, connected another dot for me when I first realized that. So puer, there's two kinds of puer tea, right? There's sheng and shu. Sheng is sometimes translated as raw, and puer, which is what I'm drinking now, that has this sort of delicious dark reddish color. Maybe I'll brew up some more in a second here. Is sometimes translated as cooked and sometimes translated as ripe. It's another one of those words that doesn't map perfectly onto English from Chinese. So what's the best way to translate it? Well, now that we have a word that makes sense, that is accurate in English, microbially ripened, well, then it makes sense to translate shu as ripe or ripened. So it's ripened puer. And that one is like, I think that is the correct way to do it. I wouldn't say cooked puer in really any situation. There's no cooking involved, and we have this natural like analog to Western foods like cheese, where it makes sense. So don't call it cooked puer, call it ripened puer, because science, right? Because science. So let me make some more tea here, and I'm gonna. Again, I always forget to move my kettle. It's really loud in the video, so let me move it down here. Hit the go button on that. So there are different kinds of fermented tea. The one that people most often came in contact with is puer. But there's lots of other kinds. And actually, the Sohan from Guanyin Tea House in Austin has a great YouTube channel. That maybe if I remember to when I'm editing this for YouTube, I'll put a card somewhere so you can click on it and go to his channel. It's called Tea House Ghost. And they just put out a video recently about a lot of different fermented teas, and it's really wonderful. So if you want to really delve into the world of fermented teas besides puer, that's a great place to start. One that I have here that I can show you guys that's not puer is called fujuan. And that's enough tea. Just ran out of water. Fujuan is this brick tea, brick tea, and somebody gave me this really beautiful box of it, and then I proceeded to re-gift a bunch of it because it was way more tea than I was going to drink. So it comes in this big brick wrapped in paper, and I've got some pieces flaked off here, so you can kind of look at it. I'll try to hold them up and maybe give you a closer look. So there's some fujuan, and I don't know if you can see. I'm not sure if it's really going to focus. Can I get it to focus on the tea and not the background? Maybe not. But there are some little yellowish speckles on there, and you can see these better in that video from Sohan. Those yellowish speckles are actually the fruiting bodies of a fungus that's on there called Eurotium cristatum, or golden flowers is what it's called in Chinese. And so that's pretty different than the way puer is made. So there's kind of a range of different fermented teas out there. So let me talk a little bit about how these are made and what the microbial players are, as far as I know. So puer is essentially, some people say, oh, it smells like compost or it smells like earth. Well, it's composted, really. What they're doing is taking processed green tea leaves, essentially green. You can argue with me about that if you want in the comments, but I would argue that raw puer is green tea. It's a type of green tea. It's a very unique type of green tea, but it's green tea. As far as those 6 categories of tea go, if you were to put it in one of those 6, it's green tea. So you take that green tea and you put it in a big pile, like a meter thick on a factory floor, and you hose it down until it's moist with just water, and then you cover it with a burlap sack, and you wait for things to happen. And what things happen are the microbes that are on the tea leaves, that are on the factory floor from the last batch of puer, that are on the workers' hands, that are on the burlap sacks, in the air, all of those microbes are starting to work and starting to do things. And a couple microbes in particular become dominant in that system. One of them is Aspergillus niger. So this is a fungus that is, it's a mold, that is the same fungus that's used in making miso and soy sauce, actually. So koji is this like grain that's inoculated with Aspergillus niger, and you can buy this if you want to try to make your own miso. You can get it sometimes at Japanese markets or something if you're lucky to have one near you. And you can actually see the mycelium, the filaments of this fungus growing around the grain. So Aspergillus niger is one of the major players. Now, it's maybe a different variety of Aspergillus niger than the one that's used for making soy sauce and miso. I'm not sure, but it probably is. But yeah, and that is something that's found, I believe, just on plants. It's on the tea leaves before they go into this process. So here is my second infusion, a lot darker. Whoa. I didn't put as much water in the teapot this time because I ran out of water. That's why. That's okay, I'll drink it. One of the cool things about puer and fermented teas in general is they tend not to be very bitter. I think that a lot of those catechins that cause bitterness get eaten up by the microbes, is my guess. Or transformed into theobrownins. Yeah, another category of chemicals. So this really dark color is a category of polyphenols called theobrownins. Different than the catechins that are in black tea and oolong, which are theorubicins and theoflavins. I believe these are produced through microbial action. I can't remember exactly. I didn't have a chance to read through that paper last night and refresh my memory. So puer is made by you're just taking whatever microbes are around, and Aspergillus niger becomes dominant. And then the other one that becomes dominant is a yeast called Blastobacillus adenovirans. And I'll put these names of these species in the description when I put this up on YouTube so you guys can read them. Blastobacillus adenovirans is a yeast. Those are the two major players. And in addition to that, there's a whole bunch of other fungi and a whole bunch of bacteria. So they're not, by any means, the only participants. They're just the most dominant participants across puers. So if you look at any sort of puer production, those are the ones that pop out as the most dominant species. Again, I don't quote me on this because I didn't have a chance to refresh my memory on it, but I believe that the Aspergillus niger is more tolerant to wetter conditions, and the Blastobacillus adenovirans is more tolerant of the drier conditions, so that the dominance of those fungi shifts as the fermentation goes on. So the pile starts off very wet, and because of the microbial action, it heats up. It gets really hot, actually, like a compost pile would. If you've ever had a compost pile in your backyard, you know that even in the winter, it can be hot and steamy in the middle because of that microbial activity. And then as it dries out, because it's losing some of that moisture, they're turning it constantly to keep it oxygenated. Then the Blastobacillus adenovirans becomes more dominant. That's, I think, how it works. One cool thing that you could do at home, perhaps, that I have done, is you can actually take some puer, right? You can have your cake of tea here, right? Here's a chunk of puer, and you can crumble some pieces off of that, and you can put them on a petri dish with some agar, some nutrient agar that I bet you can find a recipe for on the internet to make your own petri dishes, your own agar plates. And when you do that, that Aspergillus niger will grow. It's still alive. It produces these really super, super resilient spores that are able to come back to life. And so you can grow it. And I've done that before. And I can post a picture on Instagram. I did way back, a couple years back, but I'll repost it maybe. But yeah, you can actually see the Aspergillus fungus growing, which is pretty cool. So that's pretty different from how this foujuan is made. So this foujuan is inoculated with a specific fungus. Like I said before, it's Eurotium cristatum is the fungus that's used for this fou brick tea that's producing those little golden yellow flowers. And this is a fungus that is in nature associated with pine tree roots, I think. And man, there must be some amazing, amazing story as to how this tea originated. And I would love to hear it. If somebody knows, I would love to read a blog post about how this fungus got from pine tree roots into a tea that we drink. That's amazing to me. But yeah, so now what they do is they culture it on grain usually. And they use that inoculated grain to then, spread it over the tea and inoculate the tea with this Eurotium cristatum to produce the fou brick tea. Hi, Neil. Welcome. Talking about Fujuan. So, so that's really different than how puer is made. I think, I could be wrong, but I believe that it's the only fermented tea that uses a specific microbial player like that and inoculates with a specific species. I think all the others are basically more or less pile fermented like puer, and it's just sort of a mixture of microbes from the environment, from the tea leaves, from the workers' hands, et cetera, and then the one that comes out on top is the one that is best suited to the conditions. So again, it's kind of like making sauerkraut, right? If you've ever made sauerkraut or kimchi, the first time I made it, I remembered thinking it was really weird. Like, I followed this recipe, and then I was like, wait, I just let it sit on my counter now? How do I know it's gonna be the good bacteria and not ones that are gonna kill me, right? Well, the reason for sauerkraut and for kimchi is because of how salty you make it, right? You make those conditions so that only the good bacteria can survive. And so fermenting tea is kind of the same way. You want to keep the pile oxygenated. You want to keep it at a certain temperature, a certain moisture level. And the tea makers can control all those things, and by controlling those environmental conditions, they can help to ensure that, only the good guys are growing in your pile there, and there's nothing too nasty in there. Now, there was a study that came out a while ago that looked at mycotoxins. As part of the study, mycotoxins are toxins made by fungi, and there are some mycotoxins in puer tea. Yeah, there's enough in there to warrant doing a rinse. So we usually rinse puer at least once, sometimes twice, depending on who's brewing the tea. But that's actually a good idea. There's not enough mycotoxins in there that it's going to kill you, if you're just drinking a cup of tea or even a session of tea. But if you're drinking puer every day, maybe it might get to a point where you actually would worry about it. It's sort of not clear right now. But yeah, from this one study, they did detect pretty high levels of mycotoxins, of certain mycotoxins. Hello, Natalie. Welcome. Thanks for coming. And Eric says, what if you keep matcha in an ongi jar for some time? Will it ferment or ripen? There's a man who does this to his balyocha in Korea. As an ongi jar, this is one of those big ceramic jars, I'm guessing. So sounds like what you're kind of talking about is doing the sort of aging that we usually do with like oolong teas, but doing it with puer or matcha instead. And that sounds like a really cool experiment. I don't know if anybody's done that ever, but that sounds neat. I would drink that tea. You should do it. You should make that happen, Eric, because I would try it. So I'm going to talk, I think next week is the topic is going to be aged tea. So we'll talk more about the sorts of transformations that happen to tea over time without the help of microbes, like how we age oolongs or white teas possibly. So, yeah. One of the cool papers that I wanted to talk about that I'll put in the annotated bibliography on YouTube was published in PLOS One, so it's available for everyone to read. That's an open access journal. And they looked at a bunch of different samples. I can't remember how many, but 20 or so different samples of puer and puer of different ages. So raw puer and ripened puer of different ages. And they looked at the microbes. They measured what microbes were in there, the microbial community. And one of the cool findings from that paper was, there were a lot of things. So one is they also looked at fresh tea leaves, like tea leaves from the tea plant that I showed you guys earlier, sitting over there. And there's a big overlap between the microbes that are on the tea leaves in the tea plant and the microbes that end up in the finished product, the puer or the raw puer. But not 100%. So there are some microbes that are not found on that tea leaf that are in the finished cup. And now whether it could be that they're just very, very rare on the tea leaves and hard to detect, but that process of putting them in a pile and composting them basically selects for those microbes. That's kind of the thing that happens when you're making kimchi or sauerkraut. The bacteria that are important for that are very rare in the environment. They're hard to find. They're not very abundant, but they just thrive under those sort of salty, oxygen-free conditions, and they become dominant during the fermentation. So that could be what's going on there. So, but some of the microbes are coming from the tea leaves. And so, back to arguing about whether maucha, this precursor to making puer tea, whether that is green tea or not, people say, it's not green tea, it's special. It's green tea, but it is special. And one of the things that makes it special is it's supposed to be sun-dried rather than being dried through an oven, a tumbling oven or something. And it's possible, I have no idea, but it's possible that and also, the other thing is the kill green is supposedly a lower temperature, right? So it's possible that the combination of the low temperature kill green and the sort of low temperature slow drying might actually preserve more of the microbial diversity that's on the fresh leaves compared to a more traditional green tea where you're doing the kill green step, really hot wok, and you're maybe drying it in an oven or something like that. That might kill more of the microbes and might make it less suitable for fermenting. I don't know. So it's definitely special, but my guess is if you really wanted to, you could ferment any kind of green tea. If you put it in a pile and wet it and waited. But I don't know. Somebody should try that. Might be good, might be terrible. Might be pretty nasty. Who knows? So the other thing in this +1 study that I'll link to, hi David, is they looked at both raw puer and ripened puer. And they had the raw puer of different ages. And one of the cool things they found was that in their oldest raw puer sample, it was the microbial community in it was very similar to choux puer. And the older the raw puer got, the more similar that microbial community got to ripened puer. So ripened puer, remember, this was a process that was invented only in like the 70s. And the goal was to mimic a really old raw puer in a matter of months. And so sort of, what this paper is saying, at least from the microbial community perspective, it's doing a pretty good job, actually. As good as you can see from that microbial community. Now, they're not overlapped, right? The old raw puer isn't exactly the same community as the choux puer, but it's similar. And it's sort of as you get older, it approaches that choux puer community. Now, the microbial community is not everything, though, right? What we care about is what does the tea taste like? And so getting to that microbial community in a matter of months versus getting to it in a matter of 25 years is a big difference. There's a lot of chemical changes that are happening in the tea over those 25 years that are done by the other microbes that were there when it was a younger tea, which are different from the microbes in choux puer, and just sort of time, right? There's also all these changes also that are happening just because of time and because of the aging. And so, not saying that choux puer is a great replacement for a 25-year-old raw puer. I'm not saying they're equivalent, but their microbial communities are similar, which is a pretty cool result, I have to say. So, all right. I forgot to turn off my little time limit thing. Some of the other chemical changes that happen. So I mentioned the theobromines. These are these dark-colored compounds that I believe are a microbial product of the catechins. Caffeine's not changing a whole lot as far as I can tell. I've seen sort of conflicting information about whether, aged teas or choux puer are lower in caffeine or not. My guess is they're probably a little bit lower, but maybe not. It might be that the rest of the tea is getting degraded faster than the caffeine. Caffeine's an antimicrobial, so it's really not doing a whole lot of changing, I believe, in the fermentation. Another thing, though, is that you can find in choux puers, fermented teas, you can find statins. And so statins these are compounds that There's statins that are used to lower blood cholesterol. And these are microbial products. They're not something that's found in the plant at all. So that's definitely a change that's happening when puer is being made. And it's something that people have investigated a lot to see if it's helpful for lowering cholesterol, if drinking puer is helpful for lowering cholesterol and for lowering blood triglyceride levels, blood fat. And I believe that there's some limited evidence that it is good at that. One of the weird things about tea, this is sort of an aside, one of the weird things about tea is that I looked a while ago, searched on Google Scholar for reviews about tea health. So a review paper is something where you go, okay, wow, there's so much information out there about a topic that we really need to sit down and gather it all into one place, right? And so reviews are really helpful, and they're papers that sort of summarize an entire field. Well, for tea, there's been a tea review, like a major review of tea's effects on health, basically every 2 years for the last decade, which is like ridiculous. It's way more than there needs to be. And so this is really just indicative of this sort of trend of tea as a functional beverage, as a healthy, healthful beverage. We're not coming up with that much new information every 2 years that we need to have a review paper done. This is people sort of jumping on that healthiness bandwagon that affects not only marketing of tea, but also affects people that study tea as scientists, as you can see from that. So, a lot of the health claims about tea, including ones about statins and about puer being good for weight loss, being good for cholesterol, are really pretty new and are things that you should be a little bit skeptical about. Maybe I'll do one of these Tea Science Tuesdays about tea health in the future, and we can talk more about that. Although I'm a little afraid to do that because I'm afraid to get something wrong and to have somebody sort of run with it. Yeah, not sure. May or may not do that. Let's see, what time is it? Oh, I'm way over time today. I thought I was sort of under, but I talked a lot about puer and other stuff. So I'm going to wrap up there, and thank you guys for coming and hanging out for longer than normal. And I'll see you next week, and we'll talk about aged tea. So yeah, bye. Have a good day.